Lesson 5, Negative Exponents and the Laws of Exponents. What Ms. James and I would like for you to know at the end of this lesson is the definition of a number raised to a negative exponent, as well as how to simplify and write equivalent expressions that contain negative exponents. Let's get started. Alright, so the definition of a number raised to a negative exponent can be found at the top of page 17 in your binder, and this is exactly what it looks like. This is what you see in your binder. The definition is for any non-zero number, x, and for any positive integer, we define that x to the negative n power is the same thing as 1 over x to the n. Now, if you take a look at this, the definition of a negative exponent is just the reciprocal of x. So instead of it being x, the reciprocal is 1 over x. So what you're going to actually be doing is taking that negative exponent and doing away with it by having the reciprocal of the variable. Now on to exercise 3. What is the value of 3 times 10 to the negative fifth? Exactly the same thing that we just did in exercise 2. So we need to take this 3, just bring it straight down, and we multiply 10 to the negative fifth. All we do is change this, and we change it to the reciprocal, 1 over 10 to the fifth. Now, we still have this 3 sitting on the outside that we can get rid of, so we multiply 3 times the numerator, 1. This will equal 3 times 3 over 10 to the fifth power. And so now that we convert this into decimal form, what this 5 actually means is how many places behind the decimal that the numerator, the 3, will go. So we have a decimal place, 1, 2, 3, 4 zeros, and the 3 is in the fifth spot behind the decimal. So that is how you solve this in decimal form in scientific notation. Okay, so now we skip down to exercises 5 through 10. This is at the bottom of page 18 in your binder. And we're just going to take a look at these really quick. So if we start with exercise 5, we have 5 to the negative third power. And how do we get rid of that negative exponent? Well, what we need to do is take the reciprocal of it. And all we need to do is put it over 1 over 5 to the third power. Now we're done. And it's the same thing with exercise 6. We're looking at it just a little bit backwards. We have 1 over 8 to the ninth power. So how do we actually convert that back using a negative exponent? Well, if we get rid of this right here, if we get rid of the 1, all we do is we have the base of 8, and now we have that to the negative ninth power. Those two are equivalent. And with exercise 7, we have a little bit of work to do here. We have 3 times, we just carry that over from right over here. Now we have 2 to the negative fourth. So now is where we take the reciprocal of that. And whenever we do this, it's going to look like 1 over 2 to the fourth. Now, just like what we did in exercises, I believe it was 2 and 3, we now take this 3 and we multiply it by the numerator in order to condense it down a little bit. So now, once we solve this, we have 3 over 2 to the fourth power. Now, why don't you try exercises 8 through 10 at the bottom of page 18 in your binder, and we will take a look at these tomorrow during class. Please remember that if you have any questions, please write those down and we will be happy to answer them for you during class. Now at the top of page 19 we have another rule here. And if you look at the very top of this, these 3 that I'm circling right here, those are the ones that we have covered so far. And now what we're getting ready to look at is the division right here. And all that we really need to know is that we take the exponents of the numerator and subtract it from the exponent of the denominator. As you can see, they're using the variables x, a, and b. And in these next couple examples, we'll actually put some numbers to these exponents, or in the exponent's place, so you can see what's going on. Now looking at exercise 11, we're going to use that same proof that we just took a look at the top of page 18. We have 19 to the second power over 19 to the fifth power. So we still have our base of 19. Okay, and now we're going to take the numerator, the exponent of the numerator, 2, and we're going to subtract the 5 in this case, the exponent of the denominator. We're going to subtract those two exponents. So our answer is actually 19 to the 2 minus 5 power. Now, if we want to take that a step further, now we actually know how to do this. So if we solve this out, we have 19 to the negative third power. And now that we have a negative exponent, we know exactly what to do. We need to take the reciprocal. So in order to get this back in standard form, we need to take 1 over 19 to the third power, and we are exactly where we need to be. Alright, so lesson 5. Please come with your questions tomorrow to class. Hopefully by now you know how to simplify and write equivalent expressions that contain negative exponents. And we will see you guys in class tomorrow. Please come with your questions. Be ready to go. We'll probably end up doing the problem set during class to make sure that you got it. And have a good night, guys.